Hi everyone, I'm Anu Venkatesh and I'm a Senior Product Manager at Alexa AI working on Alexa Conversations. Today, with my colleagues Mariam and Adam, we're going to be walking you through how you can create natural multi-turn AI-driven experiences using Alexa Conversations, its benefits, and how it works. To begin with, and to set some context, I want to start off with talking about skills on Alexa. Think of skills as different capabilities that Alexa offers, and these may be experiences that are built by Amazon Alexa internal teams, partner Amazon teams, or even external developers and companies. Today, there are more than 100,000 skills on Alexa, reaching customers on more than 100 million Alexa-enabled devices. 4 out of 5 Alexa customers with an Echo device use skills today. There are hundreds of thousands of Alexa developers building skills that are available in over 80 countries and 13 language variants. Skill builders are creating innovative experiences today by using Alexa's automatic speech recognition and natural language understanding technologies to let people use their voices naturally to interact with content, services, and devices. At a top level, there's 2 broad categories of interactions with Alexa. The first category is one-shot interactions. This is really where Alexa started, and they have driven a lot of the growth in Alexa. These are interactions where the user goes to Alexa and says, "Do X," and Alexa does it. The user gives a command which is interpreted and sent to the backend, which does some work, and sends back an "I'm done" confirmation. For example, this could be things like checking the latest news or weather, adding something to your grocery list, or smart home interactions where you're turning on or off the lights. For skills, there is an interaction model that is represented by intents that the developer believes the user's requests represent and corresponding statements that the user may say. This is used to formulate a backend model representation for understanding the user, which works really well for one-shot interactions. On the other hand, where we see a lot of the innovation turning to in the next several years is around multi-turn interactions. Multi-turn interactions allow Alexa to have a more in-depth interaction and back and forth with the customer to really understand what exactly it is that they're trying to achieve. The core of this presentation is around how we can build more natural multi-turn conversations for Alexa, and you'll see examples of it come through all the presentation. What you see here on the screen is an example of a pet match skill that helps the customer go through and find a specific breed of dog that meets their criteria. So what you see is the customer starting out super broad, getting into the experience, just requesting, "What dog breed is good for me?" There's a lot of filters that could be applied. So in order to hone in on what the customer really wants and provide the best result back to them, Alexa is able to ask for additional parameters. And she comes back with, what are 2 things you're looking for in a dog? The customer responds with, "I want a big, friendly dog." So now big and friendly are slots or entity values that Alexa is going to use to filter the results, and comes back with another follow-up question saying, "Do you prefer high energy or low energy dogs?" And a response of high energy from the customer then results in Alexa being able to take those 3 pieces of input, big, friendly, and high energy, and come back with a recommendation of a Labrador Retriever. So this represents a multi-turn interaction where there's a bunch of back and forth between the customer and Alexa. You see Alexa and the customer really working in a joint manner to determine the best result, and where the customer asks for something, instead of just coming back with some response, there's a bunch of information exchange, allowing Alexa to have more complex interactions and do more innovative things, in turn allowing her to provide more and better results. And really, this is where, like I said, we see a lot of the innovation happening over the next couple of years. I'm going to show you a video of now a fairly complex, well-executed multi-turn conversation.
Alexa, what are the showtimes for Dark Phoenix on Saturday after 9 p.m.?
Here are the showtimes for Dark Phoenix on June 8th after 9 p.m.
Get me 2 tickets for 10:35.
Okay. 2 adult tickets for the 10:35 p.m. show of Dark Phoenix on Saturday, June 8th at Regal Cinnabar Palace Station will be $21. Should I book the tickets?
Wait, how long is it?
Dark Phoenix is 1 hour and 52 minutes long.
Actually, what are the showtimes after 7 p.m.?
Here are the showtimes for Dark Phoenix on June 8th after 7 p.m.
Get me 2 tickets for the 7:05 show instead.
Okay. 2 adult tickets for the 7:05 p.m. show of Dark Phoenix on Saturday, June 8th at Regal Cinnabar Palace Station will be $21. Should I book the tickets?
Yes, please.
You will receive an email from Adam Tickets with your tickets.
All right, so coming back. At the surface, that seems really like a pretty natural and straightforward interaction between the user and Alexa. But in reality, if you dig in a little bit, there is a lot that's going on. There was a fairly complex example of a user trying to find and purchase some movie tickets, with them actually changing some of their decisions along the way while performing other sidebar actions like trying to get some more information on the movie itself. Let's take a look at some of the challenges in particular. So first off, there's this concept of entity resolution and disambiguation. In the earlier portion of the video, the user says, "Get me 2 tickets for 10:35. On the left-hand side of the screen, you can see there's a few options that are listed for the movie Dark Phoenix. There's Regal Cinnabar Palace Station, AMC Town Square, and Regal Texas Station. And when the user says 10:35, they don't necessarily specify which theater. The system is able to resolve and identify the appropriate theater as Regal Cinnabar Palace without the user having to mention that. This in the back end is actually a hard thing to do, but it was done in a natural, free-flowing way and sort of just goes by in the conversation. Next, we have a representation of mixed initiative, where you see both parties are engaged in the conversation and really have the ability to drive it in any direction they want. For example, you see through the dialogue where Alexa and the user are both asking questions, and there's this back and forth. And it's fairly easy for any party to take control of the conversation and steer it where they want to take it. As Alexa is going down the path of completing the purchase for the customer and says, "Should I book the tickets?" the user is able to take a step back and say, "Hey, wait, how long is it?" and take the conversation down a completely different path. In this case, inquiring about more details about the movie. And at that point, Alexa is not just able to respond, but she's also able to move the conversation forward. There's also this notion of conversational context and capturing it and retaining it through the dialogue. This is something that we as humans do really well, with the ability to compartmentalize our memory with short-term and long-term data, pulling relevant context as we engage in conversations. For virtual assistants, though, context is a much harder problem. Here you see Alexa is able to actually track that. So at the very end, when the user says, "What are the show times after 7 p.m.?" she's able to refer back to the earlier part of the conversation where there was a discussion around looking for movie show times for Dark Phoenix, without the user having to say, "What are the show times after 7 p.m. for the movie Dark Phoenix?" but just express it very naturally. So all through this conversation, there's this context that's maintained, and the user and Alexa are able to refer to elements of it in a natural manner and continue the conversation forward. Now, all 3 of these things, entity resolution and disambiguation, mixed initiative, maintaining conversation with context, are fairly complicated, but when done well, the beauty of it really lies in making it seem like it was just a simple part of the natural flow of conversation without any added burden on the user and a very seamless experience. Let's now talk about the system that really made the experience that you saw possible. The experience that you saw earlier is running on what is called a dialogue management system. And dialogue managers really do three key things. Firstly, they maintain conversational state, which involves tracking entities that may be extracted during the conversation based on what the user said, or some backend process results that as an outcome of the interaction with the user. For example, the user searched for movie times for Dark Phoenix. The dialog manager is further responsible for ensuring that the state is captured and refreshed as needed so that the information does not become stale, and that becomes one of its primary tasks. Secondly, the dialog manager prompts the user to help drive the conversation to the next state. For example, in the context of the video that you saw, we see Alexa trying to confirm if the user wants to book the tickets. That's a way for her to move the conversation forward, driving it to the next state of achieving the goal that appears to be in progress, which seems to be making a movie ticket purchase. And third, dialog managers are responsible for interpreting the user's response contextually. A very common and great example of this is a user responding with a yes or a no to a question. We do that very normally. The system really needs to know what that response was in context to be able to take appropriate action. So going back to the pet match conversation that we discussed when talking about multi-turn interactions. This dialogue represents a happy path experience with the customer to provide a dog recommendation. The customer is asked a series of questions, and once all necessary information has been provided, the skill makes a recommendation. This particular conversation, as you see over here, consists of 3 turns or back and forth exchanges as shown on the screen. Now let's take a look at how one single turn comes together. When Alexa asks the user, do you prefer high energy or low energy dogs? It's same dialogue state A. With the user's response of high energy, that triggers some processes that then ends up moving the system backend state, now dialogue state B. It's a very small zoomed in version of a very simple single dialogue turn. Now zooming out a bit, if you put a bunch of these turns together, in this particular image, each blue dot represents a state of the conversation. The blue arrows represent the intended direction, and the numbered arrows actually represent the path. So if you look at it, in the situation, we have 6 turns before we get to the final response, and the above situation is called a linear multi-turn interaction. And this case is incredibly easy to build with a simple intent utterance-based solution. They're very easily designed and built out, but it really drives very linear and repeatable and somewhat boring and non-engaging experiences. Linear multi-turn experiences tend to follow a happy path where you assume the user is complying with your requests for information and the experience is proceeding as desired with nothing really out of the blue happening. What happens if the customer does deviate from this happy path? You end up with something like that. So we often say the experience that customers want is a little more complex. So in this representation, instead of a step-by-step experience that proceeds linearly, it's a multi-dimensional array where you could move from state A to B, and then the user responds with something that's completely unrelated to maybe what you prompted for, and now you need to jump to a completely different state. It's very natural for conversations to deviate from a predetermined script. Example, in the case of the ticket purchase, the user decided to ask for the duration of the movie instead of confirming whether they wanted to go through with the purchase. The user could provide more information than required at times or less, and there could be some mixed initiative happening. There's so many edge cases. In the spec match use case, you can imagine a situation where the user corrects a piece of information. So there could be loops within a dialog state and back to a state. For example, the user previously indicated they wanted a large dog. And then as they proceed, they decide to revisit the parameter by saying, how many pounds is a large dog? And follow up with, oh, you know what? Make it a small. Now, this needs to be tracked by the dialog manager to ensure the state is captured appropriately. The dialog manager needs to be able to take the information offered, contextualize it, and continue to drive the conversation forward towards the final end goal. It's these edge cases, mixed initiatives, user corrections, overfilling, underfilling, that really drive the complexity of these experiences. And we're seeing these happen more and more these days. Alexa Conversations is a deep learning approach that developers can use to create natural voice experiences for Alexa. This could mean creation of entirely new skills, or it could also be used in conjunction with custom skills to build out just a portion of the skill. And there's three main benefits that you see in using Alexa Conversations. Let's do a quick overview of the system in itself and how it solves the complex problem of creating natural multi-turn experiences, as you saw represented in the nonlinear state graph, while making these experiences feel natural and seamless. Alexa Conversations enables more conversational experiences without requiring additional developer effort for feature building from developers. We find that they're able to add new cases because of the added simplicity, and we're taking away a lot of the complexity through a bunch of features that make it easier for the developers to adopt and deploy robust and natural experiences to customers. And finally, we're able to do this with lesser backend code for dialog state management and also with lesser model training data as compared to what you need to provide for custom skills today. So just to reiterate, when we talk about conversational interactions, we're talking about experiences that need support for contextual carryover, user-driven corrections, slot over and underfilling, things that tend to happen very naturally over the course of conversations that we have with people. And what we're able to do with Alexa Conversations is offer developers the ability to support these capabilities in their experiences inherently and bring them into the conversational interfaces presented by Alexa. Here's an example of contextual carryover. Alexa starts by asking for two things the user is looking for in a dog, to which they respond with wanting a small family dog. With those two entity attributes in mind, Alexa responds with a Papillon recommendation. The user comes back now and adds another attribute saying, what about a guard dog? So now Alexa is able to use the previous context of also wanting a small family dog and query the relevant API and come back with a recommendation of a beagle which satisfies small, family, and guard dog without needing to reprompt the customer. So as you can see, there's contextual carryover being used over here for driving a user-driven update of entities to drive a more natural experience. What else? Alexa Conversation supports several advanced dialogue management features. We've already spoken about user corrections, slot overfilling and underfilling. So I want to really quickly call out one more that we haven't really mentioned previously, and that is list entity management. With this, you are now able to say something like, add grapes, pears, and apples to my shopping cart, and have the system really recognize that grapes, pears, and apples are all individual items, and have the system put all of these individual items into your shopping list. All the parsing and management is handled behind the scenes for you, so now you could actually follow up within the conversation with specific updates to each of these items as well, very easily if you wanted. Support of such features is now enabling use cases that weren't previously possible, unfortunately. And finally, like we discussed, Alexa Conversations needs fewer lines of training data. Here's a comparison based on one of our earlier experiments that we did with the movie recommendation skill. The skill is very similar to what you saw in the experience. And the original skill that was created using standard custom skill practices needed about 1660 lines of interaction model data and 5,500 lines of backend code to track where the user was in the dialogue and manage it. Once we moved that and ported that over to Alexa Conversations, we were able to drive down the number of lines of data for model training to 440. So that's pretty significant. 155 lines of API definition, which really involves describing what endpoints are you planning to call from your skill when you get to specific parts of your dialogue, and what information needs to be passed back and forth. We also have 370 lines of response templates, which basically contains responses that Alexa needs to offer back to the customer during the course of the dialogue. And this includes templated values, which could be filled in at runtime. So, in the case of the pet match example, for example, you could have, I'd like to recommend a dash, and the blank is filled in with a beagle when the recommendation is made, for example. The backend code came down from 5,500 lines to 1,700 lines of code because state management was now taken care of. So all in all, Alexa Conversations really reduces a lot of the overhead and burden on developers for creating these multi-turn experiences. And we're excited to see how new experiences can be built and brought to our customers to solve more and more complex problems and goals. Thank you.
Hi, I'm Mariam, and I'm a senior applied scientist at Alexa Natural Understanding. Today, I'm going to go into a technical deep dive of Alexa Conversations. Let's start by discussing the dialogue simulator, which is the component that generates dialogue variations in addition to the dialogues that the developer writes. The generated synthetic dialogues may deviate from happy paths, or they may contain alternate paths that the dialogue can take. This ensures that we generate enough dialogue variations to make the skill's conversational models robust to different user behaviors. The dialogue simulator takes the build time inputs that the developer has provided, including the API and slot definitions, response templates, and sample dialogues, and generates synthetic dialogues in 2 steps. The first step, the dialogue simulator generates different dialogue flows, which are alternate paths that the conversation can take. In the second step, we inject natural language variations into the dialogue flows. These are paraphrases of what the user can say to communicate with Alexa. For example, they can say, recommend a movie, or I want to watch a movie. Finally, after these 2 steps, the simulator is able to generate tens of thousands of dialogues that we use to train the skills conversational models. So let's go into more details about how the dialogue simulator works. We can look at a goal-oriented dialogue as a kind of a game between a user and Alexa. In this game, the user has a goal which can be an information need or a task that needs to be accomplished. And Alexa doesn't know what the user wants to do, but has access to some APIs and resources to help the user achieve their goal. So in this example, the user's goal is to find out about the weather, and Alexa has access to an API that can look up the weather for a particular city on a particular day. This is not like most games we see. This is more of a collaborative game in which the conversation participants take turns and perform actions in order to achieve their goals. Using this approach, let's go over an example of how the simulator generates dialogues. At the beginning, the user has a goal, so we stochastically sample a user goal. The user then informs their goal by saying, "What's the weather?" From the Alexa side, this looks like calling the Get Weather API, but Alexa sees that it needs more information to be able to address the user's goal. So it requests some slot values, in this case, the city and date. So Alexa responds with which city and for which date. User informs the slot values, Seattle today, and Alexa confirms to make sure it understood correctly, to which the user can affirm or deny, or affirm one slot and deny another slot. Here, the user affirms by saying yes, and finally Alexa makes the API call and informs the weather results to the user. In this example, the user was asking for the weather in a particular city on a particular date. So we see that as we go through the dialogue, the user's behavior is consistent with the goal. The same goal, of course, may be achieved through different dialogue paths. And simulating this is important because in real life, users display different behaviors when interacting with skills. For example, you can see on the left-hand side the case where the user is more cooperative. When Alexa asks for the city, the user responds by giving both city and date, tomorrow in Seattle. In this case, Alexa understands that the date is already provided and doesn't ask for it again. In the middle example, the user is less cooperative. When Alexa asks for city and date, they only provide the date, which is tomorrow, and Alexa understands that it needs to request the date again. In the right example, you can see a case where the user is changing their mind. User first asks for weather in Seattle, but then changes the location to Boston. Alexa understands the change of location correctly and requests the date again. Here, I gave an example of simulating different user behaviors, but we also simulate different Alexa behaviors. For example, we simulate Alexa proactively offering a skill functionality that is related to what the user is doing. And we also simulate confirming slot values or APIs. Simulating these behaviors gives us dialogue path variations in order to make our conversational models robust to such behaviors, without requiring the developers to do the extra effort of writing these dialogues. In addition to dialogue path variations, it's also important to have language variations, since different users can state the same goal differently. One way to achieve this is to do catalog sampling for the slot values. So if we have the utterance, "What's the weather in Seattle today?" we can sample the catalogs for city and simulate a dialogue variant. And we can do this for more than one slot as well. This yields dialogues with diverse slot values. If the developer has provided variants for an utterance with different argument order, the simulator will also generate dialogues with such variations. We also use paraphrases generated by a paraphrase model to generate additional language variations. And finally, we simulate speech recognition errors and interpretation errors, because in real life, Alexa could make mistakes and misunderstand the user. So we want our models to be robust to such errors. Some of the errors can be automatically recovered. For example, here, the misrecognized FOR can be corrected to FOUR, but in other cases, it may be necessary to confirm the understanding with the user and allow them to correct any errors. So how do we know if this is a good simulator? One way is to measure the amount of variation that the simulator introduces. Here we have 3 tasks of getting weather information, finding and booking movie tickets, and ordering rideshare. For each one, we compare between just adding language variations to the sample dialogues the developer has provided, and generating both language and dialogue path variations with the simulator. For each case, we look at the number of turns per dialogue, the number of unique dialogue flow sequences, and entropy of the distribution of complete dialogue act sequences. The dialogues generated with only language variations are identical to the sample dialogues provided by the developer in terms of dialogue path and show a smaller variation entropy. When we are considering dialogue path variations as well, we are simulating different configurations of arguments and user behaviors, such as user changing their mind or Alexa confirming its understanding. And so we get diverse dialogue samples and we see an increase in entropy. This sometimes may also lead to longer dialogues. So now I will go over the conversational models that we use in Alexa conversations. These models are built using the latest deep learning techniques to ensure the latest state-of-the-art performance to our users. The first model is the Named Entity Recognition Model, or NER. We have already talked about slots and how they are backed up by catalogs. Slots are units of information that need to be passed to the API or to the response templates. The NER model takes the user utterance and extracts the slots from user utterance. So for example, when the user says Seattle today, the NER model will recognize that Seattle is a city and today is a date. For this, we apply feature extractors to extract turn level and dialogue level features and pass them through context encoders. We also extract catalog features based on the domain-specific catalogs provided by the developer. We then concatenate the feature representations to obtain the final dialogue representation and concatenate it with word embedding of each token and use it as input to the model. For the final model, we use BERT with a BiLSTM architecture. The second model that we use is the Action Prediction Model, or AP. The Action Prediction Model predicts what action Alexa should take next using the current user utterance and also taking into account the whole dialogue history so far. So in this case, after the user says Seattle today, the Action Prediction Model looks at this input and the whole conversation and predicts the best action to take next is to confirm what the user just said. The Action Prediction Model evaluates different alternative possible next actions. For this, we pass the dialogue encoding that I mentioned in the previous slide through an MLP, and we utilize n-best action hypotheses using a simple binning strategy and reject actions in the low confidence bin. And finally, the last model, we have argument filling. This model fills in the values of API and response template arguments by looking at the whole dialogue context so far. It does this by picking slot values from all the compatible slots that the NER model recognized earlier. So in this example, when the user said Seattle today, the NER model already recognized Seattle as a city and today as a date. And the Action Prediction Model already decided that the best thing to do is to confirm. So the argument filling model now goes ahead and selects the value of Seattle as the input value for the city argument of the confirm template and the value today as the input for the date argument. We model argument filling as a variation of neural reading comprehension and use an attention plus pointing mechanism. We impose constraints to only fill arguments with slots of the correct type according to the action schema. So we put the simulator and model together, and here we evaluated the trained models on a ticket booking test with 50 dialogues. Again, we compare trained models on training data with only language variations and on training data with both language and dialogue path variations. Also, for comparison, we have models trained with 1,000 and 10,000 simulated dialogues. We see that in both cases, going from 1,000 to 10,000 dialogues improves all three models, and the models trained with dialogue flow variations significantly outperform the models trained with only surface form variations. This also shows the effectiveness of our data generation strategy. This completes the technical deep dive. Thank you very much for listening.
Hi, my name is Adam Hashem, and I'm a Senior Product Manager with Alexa Skills Kit. I'm going to walk through creating and annotating a dialogue using the developer portal, which is what you can see on the screen over here. Dialogues are foundational to creating Alexa conversational models. They stitch together Alexa conversation components, which are utterance sets, slots, API invocations, or API definitions, and responses. Now, the best way to get started is to create a skill using a hosted template, which is what I've got kind of started over here. I've loaded up the hosted template called WeatherBot. WeatherBot is a conversational skill that allows users to receive brief weather updates for a given location and date. Now, within this WeatherBot template, I'm going to walk through the creation of a dialog called Get Weather Requesting ARG. This represents a simple back and forth conversation where the user wants the weather and Alexa requests the missing details in order to provide it. So we'll get started with this empty dialog and then go through the two phases of authoring. First phase is entering the surface form dialog, and the second phase is annotating this surface form dialog in each of the utterances with all the Alexa conversation components. So let's start by entering the surface form dialog, phase one. So we'll start the user with the utterance, "What's the weather?" Alexa will respond with, "In what city?" And the user can respond with Seattle, which is where I am now. And we're going to do a confirmation to make sure we've got all the information correctly. So just to confirm, you want the weather in Seattle. We'll affirm with yes and do an API call here and respond with today in Seattle. The high is 92. We'll make it summer with a low of 65 degrees. Great. Now you'll notice we have these blue circles with exclamation marks. This indicates that the work's not done. There's still the next phase to go through, which is the annotation process. So let's start with the first turn, with the first utterance. So the user says, "What's the weather?" I'll select the dialog act and invoke APIs. Now, invoke APIs indicates that the user is expressing an intention to eventually invoke an API. Which is how we're going to get the weather information. Now, the APIs aren't invoked on this turn, but this starts the user on a journey to eventually invoke an API later on in the dialogue. Now, there are two general use cases for this dialogue act. Number one is the very first turn of a dialogue. Number two is after an Alexa turn with dialogue act API success or API failure, which we'll get to over here. Now, I've already created an utterance set called Get Weather. So I'll just select it over here. And if I jump into it by clicking the edit button, I can see all the different utterances that can also be used for the same turn. And this is information that the simulator actually uses to expand upon when generating training data for the Alexa Conversations model. So I can add an additional sample utterance here, weather, please. And this gets added to this data set as soon as I hit save, and it's now, once I build the model, it'll be part of the model. Now the next turn, we need to get some more information from the user. So I'm going to select the dialog act, and this is a different set of dialog acts for the user in Alexa turn. I'm going to select request args. Now request args indicates that Alexa is requesting arguments that belong to the API from the user. These arguments will eventually be used to invoke an API, but again, the API isn't invoked on this turn. It'll be done in a later turn. So I'll select the Get Weather API, which is the only API available in my skill model today. And automatically, it'll be pre-filled with city name. This is the argument that we're going to be requesting. And we've already got this request city response that's been previously created. I can jump into this, and over here we can select different responses or a visual response that'll be used on a device like an Echo Show. I can also add arguments that are passed in to be able to render the response and create the response. But in this particular utterance, it's not relevant. So let's take a look at what the audio response looks like. So if I click Edit Audio Response, I can see what's called an APLA document. Now this document basically constructs variations of responses, and it's a powerful tool. I can use it for many different applications, from randomly selecting prompts to make things sound more natural, or building them together in a sequential way. So in this example, the speech is actually broken into a few parts. So the first part, the prompt is going to say either okay or sure or nothing. For the second piece, it'll say for or nothing. And the third piece, it'll say which, what. Oh, we have what twice. And the last thing it'll say is city. So there's different ways to kind of construct this response or this prompt. So let's go through, let's hear kind of what it might sound like. So if I hit play.
For which city?
So we get for which city. And if I hit play again, we should get a different response, hopefully.
Sure. For what city?
And we can keep going.
Okay. For which city?
So just by constructing the prompt in this format, we can create quite a wide variety to help Alexa sound a bit more natural. So I'll close this tab. This is we got the green check mark, so we know we've finished this turn. And next we'll go into the user turn for Seattle, where we're actually providing information. So this is the dialog act inform args. Now inform args indicates that the user is informing the value of arguments via slots that will eventually be used to invoke an API. So in this case, we're informing that the value Seattle will be received by city name and slot type. So if I double click over here, I can actually annotate this, and I can select the slot type, city name, and I create a variable name automatically. And I can edit this with changes to something else that I like. Now this variable name will be used throughout the dialog in order to stitch together the various components. So let's see what that looks like. So I've annotated Seattle. That's sorted. I can select my utterance set, which I've already created. I've got one called inform city. And this is going to include the argument city name 0, or the variable city name 0, which helps pass in Seattle into this utterance set. And just to see what this looks like, if I jump in over here, and this may help it make a little bit more sense. So the user of this turn can respond with something like Seattle, or they could say, tell me about Seattle, what about Seattle, in Seattle, and we can create a number of different variations to expand that further. So now we've got the information, everything we need to make the API call. On this next turn, instead of making the API directly, which we could do, instead we're going to do a confirmation to make sure that we've got everything right. So to do that, I select Confirm API. Now this dialog act indicates that Alexa is confirming all the required API arguments, and optionally any of the optional API arguments that belong to the API. In this case, we're doing the get weather API again. City names automatically pre-filled. And now we can select our response, which has already been created, which is confirm get weather response. And we can pass in city name 0 as the variable. So this is the variable that was collected on this turn. So we brought in the argument, assigned it to a variable. We brought in the slot, assigned it to a variable. And now we're taking the variable and assigning it to the argument city name to generate the response. And just take a quick look at what these responses look like and how it brings in the city name. A couple of variations. It could say, just to confirm you want the weather today in Seattle, or that was for Seattle, or you'd like the weather in Seattle, is that right? So different ways to randomly select the response to make Alexa effectively sound more natural. So let's save this, and we've now annotated this turn. So this next turn, we're just affirming, so I can select affirm over here. We've got an utterance set called confirm get weather, which is the affirmation. And it's important to note that this is clearly it's indicating that the user is affirming the request from the previous Alexa turn. But this affirm dialog act almost always follows either confirm API or confirm args turn. So in this case, we're following the confirm API turn. It's also important to note that it's actually not necessary to create a turn with the deny dialog act over here. And this is because Alexa Conversations will automatically support such negative use cases on your behalf if not explicitly provided. So if a user doesn't deny the confirm API, what will happen is if the user says no, the dialog will automatically exit, and Alexa Conversations will render the recmore response to keep the conversation going. And by default, the recmore response is along the lines of, what do you want to do? So it's trying to restart the user and re-engage them into the Alexa Conversations model. So we've annotated this second last turn. Now getting to the last turn. Now this is where we're finally invoking the API. So we'll do a API success, and this indicates that Alexa is like basically notifying the user that the API was successful, where success can be defined under response condition over here, which is written in a Boolean. So over here, we'll select the API get weather API. I'm going to pass in the variable city name, which is pulled in from here, and the return type, which has already been predefined, is going to be weather results, and it'll go into a variable called weather results. So after that API is called, we'll have to do a response so we can render something back to the user. So we've got something pre-created here called gets weather response. So select that, and we're going to use the weather result 0 variable and pass it into weather results argument. And if I jump into this response over here, I can go back to editing, back into the APLA editor. And we have a couple of variations of how to render this. An example is today, and then we have the city name. It's a high of high temperature and a low of low temperature. And high temperature, low temperature, and the city name were actually all things that were provided by the API itself. I didn't have to do it that way. I could have also just had payload.cityname and passed in city name as an additional argument to the response. But instead, I chose to send that information to the API and use what we got back, what was returned from the API to render this data. Okay, and save, and there, everything's configured. So all that's left to do is build the model and then go onto the testing tab to test and play and interact with the skill. Thank you.